Alright, so next we are going to talk about the self-inductance of a long solenoid. Alright, so look at this. So there is a long solenoid here. So a current I is passing through it, and the total number of turns is equal to N, and the length of the solenoid is equal to small n. Okay, and what is N? Capital N is the total number of turns. Total number of turns. You have to be very sure about capital N and small n. That is why. Number of turns. And what about small n? Small n is equal to capital N divided by L. That is total number of turns per unit length. Number of turns per unit length. That is what is N by L. Okay. And also small n is also known as turn density. Turns density or turn density. So small n is equal to capital N divided by L. And what about capital N? Capital N is equal to small n into L. Okay. So these two n's you have to be very sure. Okay. And then magnetic field at any point inside the solenoid that we have learned in the last chapter, magnetic effects of current. So what is the equation? Mu 0 N I, where N is turn density or N upon L. Okay. Also, what is phi b? That is magnetic flux linked with the circuit. Integral B dot dA that we have learned. Integral B dot dA, substitute integral B dot dA, and it is VA cos theta, and which is nothing but BA. Why? Because theta is equal to 0. Okay. And you can check area and BA will be 0. I mean, the angle between B and A will be 0. And also, what is B? B we know, mu 0 Ni, substitute mu 0 Ni. So phi b is equal to mu 0 Ni into A. Also, this is actually the phi b due to one single portion, because N by N, like mu 0 Ni is the magnetic field associated with it. Okay, so mu 0 Ni into A is the flux associated with, flux linked with one coil. So what about N coil total? It will be N into phi b is equal to what is capital N? Capital N is equal to small n into L. Okay, flux density, the turn density into total length. That is the total number of turns. So N into phi b is equal to NL. This is what is capital N into mu 0 Ni. That is phi b. Mu 0 Ni into A. Okay, so N phi b is equal to mu 0 N square A L into I. And do you find any similarity to this equation with any other equation? Yeah, N phi b is equal to L into I. N phi b is equal to L into I. So you can substitute N phi b is equal to L into I. You can compare this equation with this equation. So this term will be L. You got it? So compare equation 1 and 2. Compare equation 1 and 2. So we can write mu 0 N square Al is equal to L. That's so self-inductance of a solenoid is equal to mu 0 N square Al. Mu 0 N square Al. Or you know that what is mu 0? It's permeability of a medium. Even if it is permeability of free space, then mu 0. What about permeability of a medium? That will be mu N square Al. Okay, so mu 0 becomes mu L. So L is equal to, also we can write relative permeability mu R. Relative permeability mu R. So this is relative. So mu 0 mu R N square A into L. So you should very sure about, you have to be very sure about this equation. L is equal to mu 0 N square A into L. Actually, this permittivity, permeability, both are like getting confused. Okay, so that is why. I mean that tongue will be like, my tongue is confused. I am not confused. So mu 0 N square. This is permeability, not permittivity. Permittivity is F7. Okay, so we have dealt with it already, right? Yeah. So this is what is the self-inductance of a solenoid or a long solenoid, and next we will discuss the energy associated with solenoid. Okay, thank you.